Hello everybody, how's everybody doing? CRS here. I am back with another video. In this video, we would be discussing about the three equations of kinematics, namely S is equal to ut plus half at square, V equal to u plus at, and V square equal to u square plus 2as. These three equations play out like magic in your competitive exams. We will also look at how to derive them today and when can you apply them and when should you not apply them. That also is going to be discussed. In addition to that, the most important aspect of using the most important thing about using these equations is the sign convention about these equations, without which these equations will definitely mean nothing. So having said that, let us first try and understand what is acceleration, and the kind of acceleration that we are looking at is uniform acceleration. Let's look at that first. So we have the acceleration being defined as the rate of change of velocity. That's what is acceleration defined as. Now, of course, the SI unit is meter per second square. This simply means that the acceleration of a body is, let's say, 5 meter per second square. What it means is that the velocity of the body changes by 5 meter per second every second. That's what it means. Now, when you are talking about equations of kinematics, then you must remember that only when the acceleration is a constant, like this one, which simply means it does not change with time, nor does it change with displacement or position or whatever other variable you can think of. If it always remains a constant, then you can say that the three equations of kinematics will hold to that particular situation. Now, having said that, we will now try and understand how to get to the equation V equal to u plus at, one of the most fundamental things in kinematics. Let's begin. Dear friends, we all know that the acceleration of a body is defined as a rate of change of velocity. You can also write this as dv equal to, maybe I'll just write it small v to begin with, dv equal to a into dt. Let us look at the scenario. There is a body and it's starting from some initial velocity, and then it goes to become, this velocity goes to become final velocity in a certain time t. The moment you start looking at this object changing its velocity from initial, and the time starts, time t equal to 0, when the velocity is u, which is the initial velocity. By the time the velocity has reached v, the time has changed to t. So this total velocity will have to be integrated, because this is only an infinitesimal velocity. This changes from initial to final, and the acceleration is a constant. It stays outside the integral. The time, my dear friends, changes from 0 to t by the time u changes to v. Integral of dv, dear friends, is v, and that has to be evaluated between u and v. That's equal to the acceleration being multiplied with t. Integral of dt becomes t, has to be evaluated between 0 and t. If you apply the limits, upper limit minus the lower limit becomes equal to acceleration multiplied by upper limit minus the lower limit. So we have v equal to, transfer the u onto the other side, you will have v equal to u plus a t. Well, with this one, that equation becomes absolutely important, and that's how you get to that equation using calculus method. Of course, you have already derived this equation using graphical method in your lower classes, so I chose to do it using calculus. Let us do the second one, which is the derivation for S is equal to ut plus half at square. Well, now velocity of a body is defined as the rate of change of displacement. So I choose to write it as dx by dt. You can write dx as v into dt. Now, dx is an infinitesimal displacement. If you want to calculate the total displacement, you will have to integrate this. But before you do that, from the previous equation, you know that the velocity is simply equal to u plus at, because v was calculated as u plus at in the previous derivation, and then I have dt here. You can certainly go ahead and write this as dx equal to u into dt plus at dt. Now, this is the infinitesimal displacement that occurs in time dt. If you want to calculate the total displacement, you will have to integrate this equation. Let's go and integrate this equation. We have integral of dx starting from 0 to s, because initial displacement is 0, final displacement becomes s, equal to u is a constant, it's history, it's initial velocity, so it remains outside the integral. Inside the integral, you have dt starts from 0, goes up to t, plus the acceleration is a, it's a constant. I told you all of these equations will only hold when the acceleration is a constant, and inside the integral you will have t dt, dear friends, and t will go from 0 to t, right? So if you integrate this, you will have x being evaluated between 0 and s equal to u in a t being evaluated between 0 and t plus a into integral of t dt would become t square divided by 2, and that has to be evaluated between 0 and t once again. Let's do this evaluation. When you do it, you have s minus 0, because upper limit minus the lower limit gives you that. It's equal to u into t minus 0 plus half into a, half into a, into in place of t square you substitute the other t out there, that's the final time. T square minus 0 square is all you will have, is all you will have. So what does s become equal to? S becomes equal to ut plus half a t square. This is the equation you arrive at, and it's an important equation. We will look at how to use these equations towards the end, but that's how you get the equation in the first place. Let's go further and look at how to derive the next equation, v square equal to u square plus 2as. My dear friends, you here have the equation for acceleration, which is dv by dt, rate of change of velocity. You can also write this as dv by dt. Well, I just want to multiply and divide by dx. When you do that, you know that dx by dt is rate of change of displacement, and that is velocity, and then we have dv by dx, my dear friends. So this is another important definition for acceleration. The acceleration of a body is also defined as velocity times velocity gradient. If something changes with distance, you call it gradient. If something changes with time, you call it rate. Having said that, this is velocity times velocity gradient giving you acceleration. Let's use that definition of acceleration to get to this equation, my dear friends. So you can certainly write v dv equal to a into dx is all you will have. So velocity will go from initial to final, and displacement x will go from 0 to s. Let's integrate this. We have integral of v dv equal to, acceleration stays outside, it's a constant, and then you have dx. This goes from initial to final, and this goes from 0 to s. If you integrate this, you will have v square divided by 2, which has to be evaluated between initial and final velocities. It's equal to a into integral of dx becomes x, and has to be evaluated between 0 and s. Let's do this. When you do it, you have v square minus u square divided by 2 equal to a multiplied by s minus 0. Send the 2 on the other side, you have v square equal to u square plus 2as. After multiplying the 2, I just transferred the u onto the other side, and there you go, you have that equation. That's how simple it is to derive these equations, and these derivations will really prove to be useful when you get a scenario, and if you just have an equation for some velocity, using these definitions you can certainly calculate the final velocity, the displacement, and all of that. Of course, these equations will come in handy if you remember them. Please do remember them very well. Having understood how to get these equations in the first place, now we will learn to apply sign convention by means of a problem. Let's look at the first question based on what we have learned just now. The velocity of a bullet is reduced from 200 meter per second to 100 meter per second. Let us try and understand this. So we have bullet that's traveling at 200 meter per second in that direction, right? It's traveling in that direction. Let me just say that it is 200 meter per second. But what happens is that it eventually, now what happens is that it eventually slows down for some reason because it's penetrating a block, it's penetrating a wooden block. Look at this. So 200 meter per second becomes 100 meter per second. It's just 100 meter per second now after penetrating a wooden block, right? So it goes through the wooden block, and now that has happened. The thickness of the block is 10 centimeter. So 10 centimeter is the thickness of the block, right? The retardation will be, that's the question. We need to find the retardation of the bullet. Look at how to do this. Let's assume that this direction is positive x direction. So your initial velocity is velocity at the end of the day. It's got magnitude and direction. So you will have to be very careful about it. Look at this. It's plus 200 meter per second because that is our positive x direction now. The final velocity is 100 meter per second because the bullet continues to travel in that direction. So this, my dear friends, is our final velocity, and that's also positive because the bullet continues to move in that direction. Velocity is a vector and that direction is positive, so plus 100 meter per second. Do you see that the bullet started penetrating the block here and then comes out of the block there with its final velocity? So the velocity has changed while it was displacing from left to right. So the displacement is also rightward. Hence, the displacement in this case, my dear friends, is also plus 10 centimeter, is 10 to the power of minus 2 meter. So the question says that it is 10 centimeter. Thickness of the block is 10 centimeter. That's the displacement. This is how you would solve the problem. Starting from initial point to final point, you draw an arrow, and that arrow is looking in the positive x direction, and that's why displacement is positive. Having said this, we will use the relevant equation in order to solve this question, because students always keep coming back to me saying, sir, I know all equations, but I never know when to apply which one. So this is the logic behind knowing when to apply which one. If you understand these concepts with a lot of clarity, then you will always invariably arrive at the result. So let's do this. We have the retardation has to be found out, because you know the initial velocity, final velocity, and displacement, and you need to find the deceleration. That the answer will definitely show you. You can simply use v square equal to u square plus 2as. That's the equation we just derived. And then we have v square, 100 square is 10,000, equal to u square, 200 square is 40,000, plus 2 multiplied by acceleration. That's exactly what we've got to find. The displacement, 10 into 10 to the power of minus 2 is 10 to the power of minus 1, which can be written as 0.1, my dear friends. When that is the situation, transfer this to this side, you will have 0.2 into a. I'm just writing this part first. Transferring it there, you will have minus 3 into 10 to the power of 4, because 30,000 can be written as 3 into 10 to the power of 4. So what does a become equal to? 3 divided by, with a minus sign, 0.2 into 10 to the power of 4. A becomes minus 15 into 10 to the power of 4 meter per second square. That is the acceleration. So that matches with option D. You know how to read that answer? The answer says that the acceleration is 15 into 10 to the power of 4 meter per second square in the opposite direction of initial velocity, because initial velocity was taken positive, or you can say is directed towards the negative x-axis. because you said that this direction is positive x-axis, by means of which these three things became positive. The answer turns out to be negative, which means the answer is telling you that this acceleration, which is a vector, is pointing in the negative x direction. This is how you understand the sign convention, without which all of these equations will be useless. So having said that, let's crack the next question. I have arranged these questions with varying level of difficulty so that you will be able to approach these concepts and problems with a lot of enthusiasm, so that things don't get very easy towards the end, nor do they become so tough that they are absolutely not solvable at all. So walk with me. Here we have a question. A particle starts from rest, accelerates at 2 meter per second square for 10 seconds. So up to this place, there is a statement, and then goes for a constant speed for 30 seconds. So there is another stage for the problem, and then decelerates at 4 meter per second square till it stops. What is the distance traveled by it? There are three things that the body is doing. It accelerates at some rate, and then it achieves a constant speed, and then it decelerates and then stops. We have to calculate the total distance that it travels during this particular event. I've told you that there is one stage, there's another stage, and then there is a third stage. We will solve it in those stages. Let's begin with stage one. So we have stage one, my dear friends. A particle starts from rest. So because it's stage one, u1 is 0 meter per second. Accelerates means it's increasing its speed. That means, let's assume that this is positive x direction, acceleration is directed in that direction, so it's a positive 2 meter per second square for 10 seconds. Let that be a1, and t1 is 10 seconds, my friends. Let's now find what is the final speed that it achieves, final velocity that it achieves, and the distance traveled by it when it is being accelerated for 10 seconds at the rate of 2 meter per second square. Let's do this. We have the final velocity achieved in the first stage is equal to initial velocity in the first stage plus acceleration in the first stage times time for which it is accelerated in the first stage. So v1 becomes equal to 0 plus a1 is 2 multiplied by t1, that's 10. So initial velocity at the end of stage 1 becomes 20 meter per second, directed along positive x axis. The main thing, we finally have to find the distance traveled. So let's also find the displacement in the first stage. It can be written as u1 into t1 plus half a1 into t1 square. When you want to do that, you have s1 being equal to u1, my dear friends, is 0 plus half a1 is 2, t square is 100. So you have half and 2 getting cancelled. You will see that s1 is equal to 100 meter. This is the distance traveled in the first stage, which is also the displacement because the body isn't changing directions. So having said that, we are at the completion of stage 1. Let's start with stage 2 of the problem. It goes with a constant speed for 30 seconds. Now let's find out what is its displacement during this time. S2 is equal to u2 into t2 plus half a2 into t2 square. But because it goes with a constant velocity or constant speed, the acceleration is 0 in this case because the body is going only in a straight line. So acceleration is 0. S2, my dear friends, becomes u2 into t2. Well, that is the situation. Initial velocity in the second case is simply the final velocity in the first case because it accelerated to that velocity and it stays the same. So instead of u2, you can substitute v1 because that's the final velocity at the end of the first stage, which is the initial velocity for the second stage, 10 multiplied by 30 because it travels for 30 seconds. So the answer you have here for S2 is 300 meter is the answer for S2. Going further, now it starts to decelerate. Let's talk about stage 3. Stage 3. it starts to decelerate. What is its velocity? Its initial velocity in the third stage is simply equal to whatever velocity it gained in the first stage, at the end of the first stage, because it has not changed its speed from then on. So we have 20 meter per second. But this time it's a deceleration, so you will have to put a minus sign, because a deceleration means that the acceleration is acting in the opposite direction of its velocity. So A3 is 4 meter per second square. It's supplied by the question. Then we have the final velocity becoming 0, because the question says that it stops. So that's 0 meter per second. Let's also find what's the displacement in this case. S3 has to be found. What is the equation we should use? V3 square equal to U3 square plus 2 into A3 into S3, my dear friends. So we have V3 square being 0, U3 square being 400, minus 2 into acceleration out there is 4 multiplied by S3. Send this here, 2 into 4 multiplied by S3 would become equal to 400, and 4 ones are, this is hundreds, so S3 would become equal to, S3 would become equal to 50 meter. So that's S3. Well, having said that, you have the total. Okay, so I think I just made a mistake here. The initial velocity is 10, it is 20, so this will become 600 meter, and then that's a 50 meter. Really sorry for that glitch in my head. Okay, so we have the total distance S equal to S1 plus S2 plus S3, and that would become equal to 750 meter. That is 750 meter. 750 meter is option A. That's the answer to this question. This is how you would solve the question for that matter. Having said that, let's solve the last question in this exercise. A car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta, then comes to rest. If the total time elapsed is t, then the maximum velocity acquired by the car is. This was asked in IIT 1978. Quite a simple question. Let's try to answer it. If you have already understood how to solve these questions already, then you should pause the video and give it a try. I'm sure you will get an answer, and nothing succeeds like success. You can go ahead and solve the rest of the problems in your book. Well, let's do this, dear friends. Well, you know that the velocity v is equal to u plus at. Let's assume that for time t1, the body accelerates at a rate alpha, and for time t2, it decelerates at the rate beta, right? Alpha is the rate at which it accelerates, beta is the rate at which it decelerates. Using this equation, because the question says that the body starts from rest, the final velocity reached would be the maximum velocity, because after that it starts to decelerate. So a v equal to 0 plus acceleration is alpha, and the time for which this happens is t1. So what do you think is t1, my friends? T1 would become equal to v divided by alpha, where v is the maximum velocity attained by it. Now this is t1. T2 is the time for which the body decelerates and then finally comes to a halt. You can again use that equation. Final velocity in the second case is 0. The initial velocity is the velocity that it had in the first situation, just like in the previous problem. Here, it's the maximum velocity v. V equal to u plus alpha a is deceleration. So that's why you must write minus beta. It's in the opposite direction of the velocity out there. Multiplied by t2. So what do you think t2 becomes equal to? Transfer this here and minus signs will get cancelled. T2 would become equal to v divided by beta. The total time of the journey question says is t. So what do you think is t? T, my dear friends, becomes equal to t1 plus t2. So t becomes equal to v divided by alpha plus v divided by beta. You can pull out v as a common factor. You will have 1 by alpha plus 1 by beta, which simply tells you that V multiplied by alpha plus beta divided by alpha into beta. So what do you think is V? V becomes equal to alpha into beta into T divided by alpha plus beta. So that's the maximum velocity gained by the car. So that's option D. Of course, this can be used as a shortcut in some other problem, but of course, if you remember the scenario, but if you know the concepts very well in a very concrete manner, then there is nothing much for you to remember in physics. With that note, my friends, I'd like to tell you that these equations are really powerful. Use them when the acceleration is a constant. Make sure that you know how to apply the sign convention. Go through this video again if you have confusions, but then do remember, the day you stop growing is the day you start decaying. Thank you so much.